Hello, everyone. Good afternoon, everybody. I'd like to thank you all to be here in the technical session number 9. That is related to power recognition applications. So we're gonna have 6 papers actually, but for only one we will not have questions. So let's move to the first one. So the first one is the work entitled An Egg Image Noise Model for Digital Visual Counting Processing. And it's going to be presented by Carlos Ramirez. So please, Manuela, you can play the video.
Hello, everybody. My name is Carlos. I am a professor of electrical engineering. This presentation is about an egg image noise model for digital visual content processing. There are several challenges for counting objects using digital image in industrial scenarios, such as image noises and image distortion. Untitled modeling is a promising approach for digital visual imaging processing due to its ability to handle cognitive problems in imaging interpretation. However, some modules need special points that are manually placed in a consistent training set or image. Artificial imaging modeling representation is emerging for image shape prediction effect in some applications. This is the key of questions. Why not consider the noise in the imaging model? Well, the proposed model is based on parametric projections, where the parameters A control the circular elliptical form, K scale the projection by axis, P is among L possible angles, M collects the data points. This is the scale parameter, and theta is the angular rotation. The full image W is composed by the union between the foreground pixels and the background pixels. W is in a RGB color space from an initial HCV color space. The proposed model J is composed by a set of egg image noise models that are common in industrial environments. The W image is filtered by a Gaussian Emory kernel, and 3 kinds of noises are added: multiplicative noise, Gaussian white noise, and Sala-Pepper noise. The matching procedure compares the egg image noise model J with the real egg image I using the MCE and HCV color space. The table 1 presents the comparative performance evaluation of previous digital visual content processing methods: the K-mean based, the global thresholding, and the proposed image noise model for both low and high diversity of chicken eggs in terms of egg counting errors. Focus on the high diversity scenario. The proposed model is the only one to achieve a reasonable performance as compared to the second best result using a real image as template. It means a comparative improvement of 9%. In conclusion, the proposed egg image noise model considers multiple aspects of realistic scenarios. The matching result obtained in the validation experiment suggests a well-expected capability of the proposed egg image noise model. comparative results show that the imagine noise model improved performance in terms of error of counting in comparison with other digital visual content processing methods. Finally, the proposed model could be naturally extended to other content applications in industrial environment. That's it. Thank you for your attention. Bye-bye.
So thank you, Carlos, for your presentation. So guys, do we have questions here while you were thinking about the question? So Carlos, you are Jaime's friend, right?
Yes, glad to be here. I am waiting for the question about the paper. The subject of this presentation is about the idea to model the noise and distortion, including in the model, which is important in realistic scenarios.
Right. And when you mean egg, right? Can be any kind of egg, I mean, or like specific egg.
The shape fit with the majority of the eggs, the ovipara,
Okay.
but the test only was performed with the chicken egg because
The chicken egg.
because the industrial application usually in industrial environment, the chicken egg is a very good business. We have special machines, special infrastructure for this kind of business. Then the scenario is focused on the industrial.
Right. Did you compute the let's say the efficiency? How fast is your approach compared to the others?
Yes, at the end of the paper, we show the comparative comparison with the time. It's not yet the main concern in this time of the research, because the first step is to recognize the scenario and recognize what it is impact in the application. The next step is to improve the relative speed. That is explained in the paper.
Right. And do you think your approach can work on like a mobile device, like cell phone or tablet, in real time?
Well, in real time, it's not yet tested because we are only modeling this kind of concept. But in the future, we suppose that is work on that, because in the future we will consider a tip chain model only on the border, minimizing the count and increasing the density of information. Maybe in this case is suitable for real application, real time. But in this moment, it's to validation of the model.
I see.
Step by step.
Yeah, sure. So do we have any more questions, I guess? So I'd like to thank you, Carlos, for
glad to be here in the name of James. Happy to be here too.
Say my hello to Jaime, please. I know him too.
Thank you.
Thank you so much, Carlos. So let's move to the next presentation. That's the work entitled Combination of Optical Character Recognition Engines for Documents Containing Sparse Text in Alphanumeric Code. That's going to be presented by Ricardo. So Manuela, can you please?
Hello, my name is Iago, and today I'll be presenting the work entitled Combination of Optical Character Recognition Engines for Documents Containing Sparse Text and Alphanumeric Codes. Let's start by the problem. Today, many companies that buy machines, parts, or tools retain documents such as notes, receipts, forms, or function manuals, and they may find themselves in the need of digitizing these documents. The problem is that these documents usually present sparse text in a non-continuous way, and alphanumeric codes that don't configure a word that would normally be present in a post-processing method based on a dictionary. So, in order to assist with that problem, we propose a combination of several pre-trained OCR models, so it is possible to achieve better recognition without training new models. Our experiment starts with line-level segmented images that are input into different OCR engines. The output from these OCR engines are done online and combined so we get a final output. And with this final output, we evaluated character accuracy, word accuracy, and the number of edit operations needed to transform the identified text into the correct one. For the input data, we adopted two datasets, the FUNSD containing 199 annotated forms and the SROI containing more than 900 annotated scan receipts. Here are one example of each. The OCRs that we explored were the Tesseract, Octopus, Kraken, and Calamari, all freely available under the Apache License 2.0. In special, for the Tesseract, 3 different versions of it were explored, the Stable, Legacy, and Alpha version. In addition to those, the OCR from the Google Cloud Vision API was also explored, but given its usage limit, it was explored only in the SROI dataset. Regarding the combinations, we explored the majority voting, ranking, and median string. The majority voting is the simplest combination approach. It consists of counting the output from all OCR engines for a given position as one vote. In this way, it is selected the character with the most votes as the correct one. The ranking is analogous to the majority voting, but instead of considering votes equally weighted, the confidence values given by the OCRs are summed to form a rank. It is selected the character with higher sum of confidence. Finally, the median string was newly proposed in this work in order to combine OCR engines. It basically works searching for a string between the group with the smaller sum of distances, and then it systematically varies all the characters in order to minimize the distance even further. In this work, the distance measure adopted was the lifetime distance, and this combination was also explored using or not confidence as weights. Finally, we presented many different results regarding all the combinations in our work, but the median string was the one that stood out as an effective method for combining OCR engines. It presented an improvement of 3.09% in character accuracy and 1.60% in word accuracy for the SROI. For the FUNS dataset, it was observed an improvement of 1.48 in character accuracy and 0.54 in word accuracy. Also, I would like to highlight that with this approach, it was possible to achieve better results by the combination of free OCR engines than the non-free Google Vision by itself. Well, that's all for now, and thank you all for your attention.
So hello everyone. Sorry, my mistake. Iago is going to be the presenter, and Ricardo is going to be here to answer the questions. So hello, Ricardo. So let's see if we have any questions or comments. By the way, let's see if our shy audience is gonna say something. But in the meantime, Ricardo, what I was wondering here, what's the meaning of sparse text in a non-continuous way?
Yes, okay. So sparse text is when you have words that are not aligned in a line or in a paragraph. They can appear in any place in the document, and they don't follow a continuous stream of text.
Like blank spaces in the sentence, or not? White space in the sentence?
Just like a form. It's usually seen in a form.
Okay,
where you have like only some words in the page that
right.
are not continuous.
Sorry.
Yeah,
I see.
Like the opposite, it will be in a book, for example, where you have all the words following a paragraph.
I see.
So sparse text is usual found in receipts and forms or even some tables in technical documents, you can find a lot of words that don't follow a fixed structure, like in paragraphs and lines.
I saw that when I saw your work for the first time, and when I read like sparse, I saw that you were dealing with situations and you have like occluded portions of the text, but your original document is sparse, right? You don't have too many things written in that space, right? That's the thing.
Yes, yes.
Okay.
Yeah,
right.
and the problem with this is that you can't use a language model with this in these situations, because a language model you assume that you have a grammar, like the words have some structure, and when you have sparse text, you don't have this connection between words. Each word can be by itself a different semantic entity.
Right.
And then we also explored the notion of codes, like so it's the most challenging form of OCR, because you don't have a grammar, because text is sparse, and you don't have a dictionary. Like you have only codes, and well, it can be numbers or words or characters. But then you can have a dictionary, neither a grammar.
And why do you call OCR engines? Is there specific why you call it engines? I mean, can be like models or something. Or I'm just asking because I do not work specifically with OCR, but why do they call engines?
It's because we use these tools as a black box, and usually it's like they are called OCR engines because they are a whole system. It's not only a model. Of course, there is a model inside of this box, this engine, but the overall box it's called an engine.
Right. We have a question from YouTube, actually. So Felix is asking you if your approach can work on documents with tables. I mean, to obtain the structure of the table or something. I think it's not a problem, right? Or we're looking for characters, right?
Consider it as sparse text, right? But we don't analyze this structure of the table itself. We only considered words, individual words.
Words and digits, right? Yeah.
Yes.
Okay. And I have another one. So, do you believe your approach can be applied to read light bills automatically? Light bills and water bills and something. You have that invoice.
Yes. That's another example where you have a lot of sparse words that don't follow a text.
All right. Davi also posted something here from anonymous reviewers. It is not clear why the rank strategy did not yield good results in the first experiment. Do you have any additional information for that thing?
That's good for me. Yeah, I won't be able to answer exactly this question, but I can follow to the main author of the text.
Sure.
Yeah.
Sure. Any more questions, guys? Let me just check. I think that is it. Thank you, Ricardo, for the interesting work. Thank you so much for your paper as well. Thank you
very much.
Welcome. So let's move to the next work, Entropic Laplacian Eigenmaps for Supervised Mathematical Learning. That's going to be presented by my close friend, Alexandre Levada. Please, Manuela, just you can play the video. Thank you.
Hello, everyone. My name is Alexandre Levada, and I'm here to present in this short video a brief overview of the paper Entropic Laplacian Eigenmaps for Unsupervised Metric Learning. Well, if we have a data set and we approximate the underlying manifold by a connected graph, then we can find a map that preserves locality from the vertices of this graph to an Euclidean subspace. Well, this map will be smooth in the sense that the idea is that neighboring points in the graph will remain close together in the output space. In such a map can be obtained by the eigenvectors of the graph Laplacian matrix. Well, this Laplacian eigenmaps algorithm is very good at recovering the underlying coordinates of the points. However, it has some limitations, especially the first one. It can be quite sensitive to the presence of noise and outliers. The second point is in datasets that do not lead to smooth manifolds, Laplacian eigenmaps has a very, its performance is severely degraded. What we mean by a smooth manifold, I mean, we have a large amount of points, of samples. So typically in small sample size problems, Laplacian eigenmaps does not perform so well as it should. Well, the question we want to ask is how to improve Laplacian eigenmaps for unsupervised metric learning. In this paper, our goal is basically to replace the pointwise Euclidean distance in the graph by the symmetrized Kullback-Leibler divergence between different patches of the KNN graph. The expression for this similarity measure is given in terms of the covariance matrices of each patch and the means of each patch. So instead of being a pointwise distance, it is a patch-based distance. So it's less sensitive to variations such as noise and outliers. In order to illustrate some results, we have here a comparison between this left side plot refers to regular Laplacian eigenmaps. We can see the classes are all mixed together. In the right hand side here, we have the result of entropic Laplacian eigenmaps, where the clusters are more separated. The features are therefore more discriminant. Well, this was just a preview of our work, and we invite you, if you are interested in knowing more about the subject, to see our presentation at SIBGRAPI. Thanks for the attention. That's it.
So thank you, Alexandre, for your work, your presentation. We have questions. Do we have questions? So in the meantime, so Alexandre, what do you mean by a KNN patch? I mean, it's a group of nearby samples. But what? I didn't understand that.
Yes, precisely. It's when you build the KNN graph, each sample is linked to its k nearest neighbors. So this set of samples, the central one plus all its neighbors, form a patch for that central pixel. So each sample, each vertex of the graph has one patch, which is composed by itself, the sample itself, plus its neighbors. It's a matrix. K, we have K plus 1 lines, and M, where M is the number of features, columns, rows and columns. It's a small, it's just a small matrix that we compute the covariance matrix and the mean vector for these samples, and we treat these samples as outcomes of a multivariate Gaussian. That's the idea.
So basically, for each sample, that's going to be the mean of the patch, right?
Yes, yes.
You compute the distance between that sample, that actually it is a patch, to all other patches in the graph, right?
Actually, we just compute the distance of neighboring patches, if they share an edge. If they share an edge, we replace the Euclidean distance that was used to weight this edge by this symmetrized KL divergence. That's the spirit.
But do you change the values of the features or not?
No.
I think no, right?
No, the features. I mean, we use all the input features to compute the covariance matrix. Yes. After the goal is to at the final step of entropic Laplacian eigenmaps, we will produce a smaller, more compact representation with less features than the input space. Let's say the final step is that we wanna reduce the dimensionality put data.
I see. Do you think we could try to apply? I mean, we could use your idea to, let's say, do some sort of to increase or to decrease the dimensionality of the space, for instance. Like SCVM, instead we can change the features, like the features for each sample that is the mean of the patch, right? It's gonna be the KL divergence between this sample and all other ones in the graph, or all other nearby patches, for it, you know.
Yes, I think I understand what you're saying. Well, I think it's a good idea. Of course, I would have to try it first to see some results, but it makes sense to think the way you are saying. It makes sense for me to do as you say.
I think it's going to be a nice space transformation, you know, that takes into account the KL divergence, but not between samples, but between patches. That's a different thing. So, you know, that's going to be nice. And I have a question from Eduardo Gastal, Alexandre. Have you tested your approach in some particular application?
Well, in a particular application, no, we haven't tested. What we have done is we chose some several data sets from that OpenML repository. it's a free and open repository with a large number of data sets. We performed some tests on several data sets from this repository, but no, we haven't tested yet on a particular application. Not yet, no.
One more question here, Alexandre.
Okay.
From Gastal, please explain why did you compare, right, your results with the results achieved by Day et al. And Dutta et al. Is there a bias in their protocols using the CIDR data set? Then, yes, it is not fair to compare your results with the other results from other researchers. I mean, why did you choose specifically these two works for comparison purposes?
Well, because we would like to run all the methods. I mean, in the paper we compared against PCA, several other methods. So we thought it would be good to compare all of them in the same set of data sets, you know. So we chose, and moreover, we would like to perform a statistical test to assess, to check if the average performance was improved or not. So we selected, I guess, 25 or 30 different data sets and compared our method against PCA, regular Laplacian Eigenmaps, isomap, LLE. We would like to have a large N to perform the statistical test. So we have to choose several different data sets. So that's the motivation. The idea.
Okay, that's good. Well, I think that is it, Alexandre. We don't have any more questions, so I'd like to thank you again for your interesting work. Thank you so much.
Thank you. It was a pleasure to be here. Okay.
Bye-bye. Thank you.
Bye-bye.
So let's move to the fourth presentation, performance analysis of chess players compared to traditional novel cognitive perception ranking measures. That's going to be presented by Lars. Manuela, please.
Hello, everyone. So here I'm going to talk about the paper entitled Performance Analysis of Chess Players Comparing Traditional and Novel Cognitive Perception Ranking Measures. So the idea of the presentation is to have an introduction, and in the introduction I will tell you about the reasons that chess was chosen as the environment to carry out this experiment and the goals that we have in our paper, apparatus and participants that I will explain, the equipment that were used here, and the volunteers who participated in this study. After this, the experimental design and data processing. So in this case, talking about the experiment itself with some details, so how the test was showed to the volunteers and how we process this data. After this, the metrics of proficiency evaluation. In this case here, talk about the metrics that we propose here and the traditional metric that is used to evaluate proficiency in chess. After this, the results that with the experiments that we have carried out, and to finish, the conclusion. So here just one of the results, just to have an idea, to analyze one of the volunteers, analyzing it with the traditional metric, with the eye tracking hyperplan, and the EEG hyperplan. So with the eye tracking, it's possible to check two different things, the scan path. So in this case here, it's possible to see the sequence and the important points where the volunteer has looked at the screen, and with this generate a heat map, and together with this it's possible to check the head plot to check what parts of the brain had more activations, and with this it's possible to check a brain map and see the most important areas that were used here. So this is just an idea about what we will decide in the complete part. Thank you so much.
So Carlos.
Hi.
So thank you, Carlos, for being here. So do we have any questions, guys, for their work? So just let's see if we have something. So Carlos, there is like a main motivation for choosing chess players instead of any other game?
I think the main reason is essentially because this is a well-framed game with very well-established questions, and in that specific case, the participants were essentially composed of players from a championship, several championships in São Paulo. So, and also there is, of course, some interest from ourselves here at our lab to try to understand what exactly is going on in the brains of these players when they play chess. So it's a mixture of motivations.
All right. I think this area of, let's say, perceptual learning or perception measures, we have seen a lot of nice works in this thing. It seems like popping up, right, nowadays. So I think that we have questions here. Lars is here too. So I have one question from Davi, right? So we got this one here. I also found it odd that Greyscale conversion of the heat map is discussed as the heat maps generated from scalar data in his understanding.
Yeah, the idea to change the heat map from RGB to Greyscale, it's because the idea was to work just with a two-dimensional matrix. So we changed it. So we put the range from red to green, the colors that we have in our heat map, to 0 to 255. So in this case, we could maintain the results from the heat map, but changing it to a 2D dimensional. So that was the idea to change it.
And right. Another one here. You have some actually. So how do the authors combine the information of all the 10 questions per task?
In the total task, we had 50 questions that were divided in 5 categories. Each category we had 10 questions. So first of all, they were randomly chosen to be showed to the volunteers, right? And the volunteers needed to answer to these questions, answering yes or no. So 10 questions per task, not necessarily 10 questions per task, but 10 questions per category that we have separated, because each category was necessary to solve a different part of the chess game.
And also, I think the last one is more or less related to your answer. So one here is like, but why is meaningful to use a channel entropy approach with correlation instead of traditional one that uses probability?
Okay. Because the idea, when we studied the brain signals, the idea was to study the brain as how each part of the brain correlates to each other. So the correlation was done with one channel with all the others. In this experiment, we have used 16 channels, and we have used the correlation with each one of them with all other 15 channels. So that was our idea here. So the idea was to correlate all of them together.
And essentially, and I think just to complement, essentially the idea to have the entropy of the correlation is that you would probably have some areas of the brain that would respond for that specific cognitive phenomenon or test that you have to do. And if essentially entropy is zero, so there is no areas activating simultaneously. And if it's one, so essentially all the brains activated, something that probably is not related as well. Would you like to actually have the entropy to have these middle values between 0 and 1 that would describe better this phenomenon?
Nice. That's good. Well, I think we have all the questions answered. So thank you so much, Laerte and Carlos, for your interesting work. Thank you so much. So let's move to the next presentation. An offline writer independent signature verification method with robustness against scalings and rotations. That's going to be presented by Felix. So please, Manuela.
I present our work on offline writer independent signature verification method with robustness against scalings and rotations. Handwritten signatures are widely used for biometric authentication. Signature verification consists in verifying whether a given signature was generated by a particular person. Signature verification algorithms allow us to automate this task. For example, we see here a genuine signature from a particular person, and on the right-hand side, we see a forged signature trying to mimic the same person. A signature verification algorithm should classify the first signature as genuine and the second one as a forgery. This can be done, for example, by comparing these signatures against a database of signatures. Our contributions are a new offline writer-independent signature verification method based on the idea of moving least squares, and robust against changes in scale and rotation of the signatures. Also, a proposal of variations on existing datasets to consider scalings and rotations, and a discussion on the bias in signature datasets with a proposal of how to remove such bias. We also perform several experiments and a small user study on signature verification tasks. Now, we briefly describe technical details of our proposed method. Please see our paper for a more detailed explanation. Given a pair of scanned signatures, the goal of our method is to classify this pair as either genuine, when the signatures belong to the same writer, or as a forgery, when the signatures are from different writers. In order to achieve classification, we propose the use of hybrid features composed first by handcrafted features based on moving least squares, and second, by features obtained from the clipping neural network with a new preprocessing pipeline. Finally, these hybrid features are used as input to a single SVM classifier. In the following slides, we briefly describe the feature generation process, starting by our moving least square features. The intuitive idea behind our proposal is that pronounced curvatures and stroke intersections are the most difficult part to imitate when trying to mimic a genuine signature. We extract such geometrical and topological features using moving least squares. Small square neighborhoods of the signature are fit to weighted least square lines, and we use R-square coefficient as a measure of the goodness of the fit. Pronounced curvatures and stroke intersections will be associated with smaller values of the R-square coefficient, as illustrated here. Finally, R-square coefficients are converted to feature vectors using histograms. Let us now discuss our CNN feature generation. We found that the clipping neural network produces a set of features that generalize well for our signature verification problem. We propose a new pre-processing pipeline for this network, since signature images have different aspect ratios and padding areas, as illustrated below. We generate 3 overlapping crops for each signature. and clippy feature vectors from each crop are combined into a single feature vector using an element-wise vector sum followed by L2 normalization. Note that the default clippy pre-processing pipeline only considers central crops and does not generate good results for signature verification. We show here the complete overview for our proposed method. Note that at the end we have a feature vector size of 2,274 dimensions, which consider features from both signatures in the signature pair. As mentioned before, these features are used as input to a single SVN classifier without any fine-tuning of the SVN hyperparameters. Now, we will talk about the experimental results we obtained with our proposed method. As we can see, for an unbiased version of CEDAR, our proposed method outperforms the other methods and even humans with accuracies of nearly 100%. The same situation is repeated for rotated and scaled versions of the dataset, showing that our method is robust to rotations and scalings. We would like to thank these individuals and institutions.
So thank you, Felix, for presentation. So I have a question here from David. How do you localize the signature in a scanned document? I think that's the first question, right? And the second one is, can you both localize and verify that signature in a single step?
Hi, Joao.
Hello.
Actually, we are not doing signature localization now.
I see.
Our
You have
method
the signatures ready, right?
Exactly. We have worked with some data sets that have the signature images already located.
Yes. Right. Right. And that CEDAR data set, do you know how many samples does the data set have?
We use 3 data sets. One of them have 55 writers. Each writer have 24 examples of genuine signatures and 30 examples of forged signatures.
Right. I was just wondering because you have, the number of features you have is not like, let's say, compatible with the number of samples you have, and nicely you got very good results, right? With have you tried? Did you test any other classifier than SVM, or you just
we tried different configurations for the SVN classifier, different hyperparameters, but the default parameters achieve the better results.
The default parameters. Yeah.
Yes.
Which kernel?
Sorry, I don't understand.
Which kernel did you use for SVM? RBF or polynomial kernel?
RBF. It's the default. But actually, I mentioned that the dataset have 50 writers, but we generate signature pairs now, combining genuine and forged signatures. So at the end, we ended with a number of sample of something about 30,000 of samples, 30,000 combinations.
Right. What if you have two modules, right? The moving least squares, right? And you have the CNN, and they are combined. So which one do you think plays the major role in your system, if there is one? What do you think?
Actually, the CNN provides the the most of the accuracy of the model now. But our handcrafted features obtained from moving these squares provides robustness against changes in rotations and scales. So the combination of the two kind of features ends with a model that have good accuracy in different scenarios now.
Okay, nice work. I think we don't have any more questions, I guess. So I'd like to thank you, Felix, for your nice work. Thank you so much.
Thank you. Was a pleasure to be here.
Thanks so much. And then let's move to the last presentation of this technical session. It is entitled A Form Understanding Approach to Printed and Structured Engineering Documentation. That is going to be presented by Vanessa. So please, Manuela.
Hello, my name is Vanessa Teles, and this presentation is about a form understanding approach to printed and structured engineering documentation. We propose an information extraction method for structured documents with an anchoring relationship between question-answer objects through a system of hypothesis and probability in order to identify which predefined model the document belongs to, thereby acting as a system for both identification and content extraction to structured documents. We divided our methodology into two main document classes, but the first steps are the same for both of them. In the pre-processing step, we apply noise reduction, binarization, skew detection, and reduction to increase image quality and helps the data extraction. Then we apply tesseract to extract printed text from the images. Next, we have this big step that we call form understanding, where we classify the documents through a probabilistic approach using the layout similarity between the document and the models previously defined by users. Then, we extract the useful data and store it in a JSON format. For data extraction, we use an anchoring system in which elements of the documents are identified as text, question, or answers. Both the text and question types are elements whose target, value, and position are known. On the other hand, even if the coordinates are kind of known in answer type elements, their content is not. That's why, to assign a semantic relation depends on anchoring the answer to question type elements. In that way, a hierarchical link is established between the elements composing the question-answer bound we propose in the algorithm. But how it is done? With the result from tesseract, we group sequence of up to 5 close words together and call it a block hypothesis. Then all hypotheses are transformed into a set of features following the tuple, with T being the word and the other elements representing the word's bounding box. Hypothesis probability value is used to define whether the hypothesis belongs to a block in the model. It attributes a similarity score between the processed document and the model in question. We calculate the hypothesis probability for each block as in this equation right here. The bounding box probability when the block is a question element is made in regarding hypothesis coordinates and blocks coordinates. For a block with an answer element, a verification is made regarding the hypothesis coordinates and blocks coordinates. However, since we anchor the answer to the question, the block coordinates are given as this equation right here. We calculate the test probability by the hypothesis using Levenshtein distance, and among the possible words, we choose the one that presents the best distance value. Document classification can be executed in two different ways. For Class 1, document classification algorithm extracts blocks from the page using block hypothesis probability, along with block probability. For Class 2 documents, the title information is extracted using the regex tool. The coordinates of all possible titles positions are mapped. Therefore, the algorithm can identify which model does the title belongs to, and the element extraction is made based on the selected model rules. All experiments were performed using document provided by a private organization and has sensitive data. To provide examples of question and answer types elements, this image shows a result sample of non-sensitive data detected by our method. The word data, date in Portuguese, is a question type entity, and the date itself is an answer type entity. The dataset has 11 different types of databooks, which are sets of technical engineering documents. All the documents were scanned and stored as PDF. To validate and have comparison metrics, it was necessary to count how many entities of interest the documents had. The mentioning process was performed through a validation algorithm that compared the expected number of elements and the number of elements found by the information extraction system. For that, the entities were separated in 3 classes, which are text, question, and answer. Here we have the results. In general, all models achieve promising extraction results in both classes, which validates the good performance of our approach. Although improvements need to be made, the method worked effectively and achieved positive results on the proposed task. As future work, we intended to improve the information extraction in structured documents up to 90% in all documents, explore other probability distributions and methods, as well as implement a method for information extraction of semi-structured and unstructured documents based on deep learning to automatically set up the models to work for other cases. Thank you for watching. It was a pleasure to be here. I hope you have a nice day.
So thank you, Vanessa, for your presentation. So
Hello.
Let's see if we have questions. In the meantime, Vanessa, so basically your work is kind of, as you said, form understanding, right?
Yes.
Have you thought about, after you identify the entities, right? You show it like dates and names, I don't know. Have you thought about somehow use that information, like to structure that data in some sense we can understand the relationship between these entities, you know, and then to try to, I don't know, classify the document in another level or to extract another level of information from the forms? Maybe the future work or something.
Actually, when we extract the information, we already has this link that we call answer and questions anchoring system, that we just want to find an answer if we have the question, because it doesn't, we cannot do anything with just or the answer if we don't know what the question is. So our output is a JSON file that has this structure of question and answer. So it kind of gives a sense of understanding what is happening in the document.
So there's one comment here from David. The domain of the document, right? It is engineering for shipbuilding and offshore industry, right?
Yes.
Okay. So however, it's not clear why other strategies, like a view or something, could not be used. This brings the question, it is a domain-based approach or an ad hoc solution? I mean, your approach, right? It's going to work only in this domain, or maybe you can extend it to other applications?
I think we can extend for other applications with a bit of modifying it a little bit. Just our documents, they are kind of hard to understand even for a human being if you are not a professional, and that is way more hard for a algorithm to understand. We have a lot of answers. They are codes, so we have strings with letters and numbers. They can be a question for more than an answer for more than one question. And it was kind of hard to try to use like other methods that are based on content and semantic relationship, because we don't have that.
I see. So one more here from David too as well. Since the implementation of rules, right, in a rule-based approach is manual, human knowledge is direct transfer to them, like assuring their quality. So do you have some idea about the time required to for the user to find these set of heuristics, you know, the set of rules?
Nowadays we have a tool to describe the. It's not manually anymore, but before it was manually. But even if it takes some time, I would say some 2-3 hours to describe a new model, it's still it's less than what a professional you'd have to take time to understand if that document it has all the normative it needs, if it has all the information it should be here. So
right. Okay, maybe this answered David's last question, I guess. Or maybe if David wanna add something, but I think you have answered.
I see his question. Yes, it's a bit in disadvantage comparison to deep learning methods. But the thing is, with our project, we didn't have a lot of budget, so we didn't have the required hardware to make to implement something with deep learning. So we had to kind of work with what we have, and that's why I think the contribution is small, but it shows that you can make a lot of things with a small budget.
Yeah, that's interesting. Actually, just a final remark. I have just reviewed a paper today, and they show that you can obtain way better results with a simple architecture for question answering, using a very simple architecture, but with proper parameters tuned. But I mean, they took 20 months, 20 months to fine tune the architecture, like a year and a half to prepare
it's
the paper.
It's a lot of time.
So, yeah. But I mean, it's a different finding, but it's nice as well. No, that's good too. So I think that is it. Thank you so much, Vanessa, for your work. And also I'd like to thank all the audience here, all authors, all questions, and also I'd like to thank the invitation from the general chairs, and also invite you for to attend the next technical session that's going to be related to segmentation features and classification. That's going to happen like in less than half an hour. So see you there. Thank you so much and have a good one.